some basic database terms. Today I'm going to walk through what data and information is. I'm also going to take a look at how modern relational databases are built and work. We'll briefly explore the concept of relationships. We'll look at queries. I'll look at SQL. We'll also use SQL Server as the base for this particular discussion. Alright, so let's start off with data. Data is simply a collection of random facts with no organization. They're just numbers. They're just words. They're just statements. We all know what data is. We've all seen it. But sometimes we misinterpret the phrase data versus information. So data is this. Numbers. Could be anything. Could be batting averages for a baseball team. Could be room numbers. Who knows? Could be combinations. This is simply random facts. They mean something to whomever typed this particular spreadsheet. As a computer person or as a business professional, you need to move beyond random facts. You need to put together information so that I can look at the chart and understand what these numbers are. That's where information comes into play. Information is simply data with meaning. It's the same numbers, but now it has context, or it has meaning, or it has an understanding. That context is really important. So I'm going to show you the context of the same numbers. It's my weight over the years. I have a weight problem. So you see 215, 216, 220. March, I'm pretty heavy. April, May, I start to lose a little bit. Over the summer, I go outside a lot and ride my bike and maybe play soccer a little bit. By October, I'm eating candy again and weight's going back up. So now these numbers mean something. Now you can look at this and go, oh, okay, I get it now. Remember, information with meaning, data with meaning. What's this? Oh, I know what this is now. So as you put together your output for your SQL queries or your programs that you're writing, always make sure that a user could look at your output without looking at the code and understand what it is you're saying. That means your output is that information. So let's move this into the database world. A database is a collection of information related to some common theme. They can be stored in one or many files. They'll all be based on the same data. So the example I'm going to use throughout much of this lecture is going to be a weight loss database. So my weight loss database will be my theme. I'll have customers, amount of weight if someone's lost, trainers that are working with them. That's all related to a common theme. What you won't find in there is book information because database for weight loss doesn't need books. Likewise, you won't find movie information. Those are separate databases. I could somehow bridge them if I wanted to, but typically they're distinct. Within the database are a variety of other terms that we'll come across. So the database is a generic term for a collection of information. Google is a big database. IMDb, the Internet Movie Database, is a big database. Amazon sits on top of a database. You've interacted with databases probably the majority of your life. If you have a social media account anywhere, it lives on top of a database. If you want to be a successful computer programmer, information technologist, business analyst, systems analysis, or you just want to exist, you have to understand what databases mean and are. To work with a database, you just don't want to deal with stacks and stacks of data. Few people like that. So we need something that brings order to the chaos. That's what DBMS is. Database Management System. Database Management System using SQL, Structured Query Language, acts as the middle ground between your user's software and data. So here's our fitness database. Okay, it's living on a database management server, and I chose SQL Server for this example. Others exist, and I'll define them in a few minutes. So the DBMS talks back and forth with the fitness database. My customer, when they go to log weight, they have created some type of interface that allows them to connect to SQL Server, and it records the database here. The customer doesn't talk to the database. The customer talks to the interface that I give them, which then talks to SQL Server, which talks to the database. Likewise, my employees, they have some type of interface that allows them to connect to the SQL Server, which then connects to the database. They never directly connect to it. The SQL Server is between them. It's very much like when you go to a restaurant And you sit down at the table, and the waiter or waitress comes up and says, "What would you like to eat?" And you tell them what you want to eat. And then they go in the back and tell the chefs what you want to eat. There aren't many restaurants where you go in the back and cook yourself. So this SQL Server acts like that waiter or waitress, where it's the intermediary between you, the customer, and you're the kitchen. And now down here, I've got a website here because programs interact with SQL Server as well. All programming languages can talk to a database. What it means is they can ask database queries. The database management system will pull the information out of the database and deliver it back to the website. That's precisely how Facebook, Instagram, Amazon, Google work. It may not be SQL Server here, but it will be some type of database management system that sits between the interface you're looking at for Amazon and Amazon's collection of stuff they sell. Okay, so the SQL Server here, or database management system, allows people that are supposed to access the data. It also grants access to people in software, those that need it. So you see I replaced our people up there with hackers. With a little bit of effort, and it really is a little bit of effort, you can block most people from accessing your database. Now, the good hackers in the world will find a way around it. I mean, that's what they do. They're really good at what they do. But for the average or even above average computer person, a very quick check on saying, no, you can't access this table would hide that table from a user. So the DBMS system grants access to people or software that need it and protects it from people that don't need access to it. In this course, we're going to talk about relational databases only. A relational database uses SQL to connect data based on common information. So let's take a look at this is what's known as an ER diagram, an entity relationship diagram. The entities are the tables, the relationships are the lines between them. So look at my customer. My customer has a primary key called cust ID. You'll notice that all of my tables have a primary key. That's a pretty big tenet of relational database design, is all tables should have a primary key. So my customer ID is a number. I've chosen a number. So customer 1, customer 2, customer 3. You are used to primary keys. You have a credit card probably with a 16-digit number. You have a cell phone that's got both a cell phone number and an IMEI number. Your car has a VIN. These are all primary keys. They're designed to guarantee uniqueness. There might be 2 Lee Cottrells in my customer database. The customer ID guarantees us uniqueness, so I don't get his weight information, he doesn't get mine. So here I have a table with first name, last name, starting weight, goal weight, my height in inches, and who's training me. I have a relationship between my customers and my trainers table. The trainers are the people that are yelling at you, to do 10 more push-ups and run faster. The way I've set up my database is each customer has precisely one trainer. So I've got a relationship here. Trainer ID is in here, not first name, last name, but trainer ID, so that I don't have to type a trainer name twice. The way that this line reads, and this is the Microsoft SQL Server version of an ER diagram, one trainer has many customers. In this database, I have 1,000 customers and 15 trainers. So these guys are going to have a lot of people they work with. Likewise, whenever I schedule a training session with my trainer, one customer will have many training sessions. And you see my training session ID has some type of session ID. It's just a number. Trainer ID links to here. One trainer will have many session IDs. One customer will have many session IDs. I have a date and time and then whatever notes I want there. Since it's a weight loss database, I record my weight once a week, once a month, however I want to do it. I just put the customer ID here, so I don't have to worry about which Lee Cottrell is this. It's the only Lee Cottrell with customer ID 42, period. So customer ID 42 here, the data recorded the weight and what my weight is now. This is a pretty standard designed relational database. If you're an expert in relational databases watching this, you might reacting to how I chose my primary keys. I did it for simplicity. As we go through the course, we're going to learn how to design databases like this, and we'll learn about some design constraints like different types of primary keys, composite keys. But for right now, I kept it simple. What you need to understand about relationships and relational databases is they make your life easier. They reduce the amount of data you have to type. I have 15 trainers. I only have to type them one time. I could have multiple repetitions of those. And with this simple query, I can list my customer first name and last name and the trainer first name and last name that are working with them. Likewise, with this relationship, I can list my customer first name and last name and every weight recording they've had. I could even do a simple calculation that takes subtract starting weight minus weight in the most current entry and see what this person has lost. This is all doable with SQL. Now, if you've programmed before, a lot of the stuff that we're going to do in this class in SQL will amaze you, because to do the same thing in Java or C++ would be dozens, if not hundreds of lines of code, and we're going to pull some of this off in 3 lines of code, 4 lines of code. SQL is incredible. Remember that SQL stands for Structured Query Language, and every relational database management system on the planet uses SQL. So even if you're learning SQL Server at your school or Oracle or PostgreSQL, it's still SQL, and you can move from place to place. There are subtle differences, but they're real subtle. With that being said, here are some of your most popular databases: Microsoft SQL Server, Oracle Database, MySQL. Oracle and Microsoft SQL Server are expensive. SQL Server is on the order of $26,000 per core per CPU. That's a lot of money. Now that's an estimate. Actually, pricing these things is very complicated. If you want to buy these things, call somebody or email somebody. They'll walk you through the pricing. Luckily, SQL Server has a free version called Express that you can download and install on your own machine. It does just about everything the $26,000 one does. Oracle is similar to SQL Server. It's expensive. The reason they're so expensive is they'll hold terabytes of data. SQL Server will hold something on the order of 500,000 terabytes of information per database instance. That's a lot of data. Oracle's in the same ballpark. Ridiculous amounts of data. They also are really good at cranking through this data extraordinarily fast. MySQL is owned by Oracle. MySQL, though, is a free open source database. Not quite as big as SQL Server, not quite as big as Oracle, but plenty powerful. From my experience, for-profit companies use SQL Server and Oracle, where non-profits might use MySQL. All are exceptional, really. These things live locally or on the cloud. You can install these right on your server, right on your computer, depending on which one you get. Or you can, for a small amount of money, put these in the cloud. By small amount of money, I think for Microsoft Azure, we're averaging about $5 a month for a SQL Server database in the cloud. Now that's the bare bones, smallest SQL Server you can get, but still, that's not that much money. We only use it for a couple months, so it doesn't cost them that much. You can also spend thousands of dollars a month if you're not careful. AWS, Amazon Web Services, is similar to Azure in what they offer. They're both exceptional products. I use Azure more than AWS. It's just preference. It's not that Azure is better. It's just I have more experience with it, so I go with what I know. So you've got lots of choices out there. And again, these are not the only 3 choices. There are many, 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 many more. These are just 3 of the more popular ones. All right, so what we've got here is an example of a table. A table is a building block for a database. It's going to have rows and fields. Now, rows are these guys: Andy Dowse, Ron Golly, Noreen Pottery, etc. Fields are the columns. Depending on what database books you're reading, you might hear records as called tuples and fields as called attributes. They're all the same thing. It all depends on how mathy the book is. In this particular output, customer ID is the primary key. Customer IDs have to be unique. So I've got 1, 2, 3, there's 1,000 elements in this table, so all the way down to 1,000. These will never repeat. First names could repeat, last names could repeat, starting weights could repeat, etc. But customer ID will never repeat. That's the whole point of a primary key. It guarantees something unique in your records. Data is going to be stored in your rows and fields in your tables. So we've got data here. Like here is that first record. This is a record which will be stored in a table. This record will be stored in a database, and this database will look like this in SQL Server. You have the cylinder, which is the universal symbol of database. it has a bunch of folders under there with my 4 tables. When you look at this in reality, here it is. This is SQL Server Management Studio, which is the interface to SQL Server, and allows you to take a look at the information there. Now, when I go to work with this, I'm not going to spend a lot of time as a database person working with rows and fields. We'll gather that stuff with apps, interns type this stuff in. As a database administrator, you're more concerned with pulling this stuff out. That's where SQL comes into play. A SQL query is a question asked of a database. So here's an example. The 3 blue keywords are select from where. It's probably the 3 most important SQL keywords you'll ever learn. Select is the list of fields you wish to pull out. From is the table or list of tables. And then where are conditions. You don't have to have conditions. The way it sets up is select, list your fields, from the table, where. And this one is pulling out people that are weight between 200 and 300 pounds. Let's see this live. So I'm going to create a new query here. Let's list everything from trainers. In SQL Server, the semicolon is optional. In every other SQL environment, the semicolon is required. I have 15 people in my database, trainers. Select start from trainer. Here they are. If I want to do a condition on a trainer, I'm going to search whose first name is Denise. And there she is, assuming. See, I can just highlight sections. If I just run up here, they both run. As you learn database, you spend a lot of time on these select statements. You're going to get real good at them. Now, you might be wondering, why do I care? It's a bunch of reasons you care. One, job prospects. Every company on the planet uses databases. You can work anywhere. They're all looking for people. So it's a great job prospect. 2, searching data is really simple. You saw all that. If you've programmed, if you've written the algorithm to search through an array before, where you have to write the for loop and walk through it one line at a time to see if it's there, you know how much work that is. And that was simple. Select line. Data storage, likewise, is simple. When you start learning how to do real programming, you started by learning how to write to files, and that's fine for 10 lines. But you have 100,000 pieces of data you want. You don't want to write that to a text document. Databases will make that run faster and better. Sharing is easy. As I pointed out, I can put this up in the cloud, and I can share the database across multiple programs or platforms. You can even have a database that reads from SQL, Android, and Java all at the same time. You save space because you reduce redundancy. If I look back at this database here, I don't have to worry about retyping Olivier Bergeron again, or pronounce the guy's name. I could select my trainers and my customers and not have to repeat these names. So I'm going to show you that. I'm going to show you a join here. I'm going to list the customer's first name and the trainer's first name. What I'm doing is I'm doing what's called an inner join, and I'm going to join these 2 tables. Now, the reason I'm doing this is I want to show you that I don't have to type Olivier so many times. It's just simply limited to Olivier. Olivier is responsible for 93 of my customers. But if I look at my customers table, you'll see that the Olivier name's not here. It's not here because I know it's in my trainer table and I can join by it. So I didn't have to type Olivier 93 times in my database. I typed it once, created a relationship between customer and trainers, and used that relationship to display the customer first name and the trainer first name. All right, that's it. Good luck to you. Have a good day.